Hi everybody, welcome back. Mike Baugh here. Today we're going to talk about heat exchangers, the heart of the LNG plant. Heat exchangers are critical components in the liquefied natural gas or LNG industry, primarily because they facilitate the cooling of natural gas to extremely low cryogenic temperatures, around -162 Celsius or -259 Fahrenheit, to transform it into a liquid. This liquefaction process significantly reduces the gas's volume by about 600 times, making it economically viable to transport over long distances, especially by ship. Heat transfer. There are three fundamental types of heat transfer: conduction, convection, and radiation. These processes describe how thermal energy moves from one location to another due to temperature differences. Conduction. This is the transfer of heat through direct contact between particles. In solids, especially metals, heat is conducted as vibrating atoms or free electrons pass their kinetic energy to neighboring atoms. Convection. This involves the transfer of heat through the movement of fluids, liquids, or gases. Radiation. This is the transfer of heat through electromagnetic waves, and it doesn't require a medium, like solids, liquids, or gases, to occur. Key applications of heat exchangers in LNG. Heat exchangers are used throughout the LNG value chain, including natural gas liquefaction. This is the most prominent application, where natural gas is progressively cooled and condensed into liquid form. Regasification. At import terminals, LNG is heated back into its gaseous state for pipeline distribution. Gas sweetening. Removal of impurities like H2S and CO2 from natural gas. Gas drying. Heat exchangers can be used to preheat or cool natural gas streams to remove water and prevent hydrate formation. Preheating natural gas. Before expansion in turbines, natural gas is often preheated using heat exchangers to prevent condensation of heavier hydrocarbons, which can damage the equipment. Boil-off gas, or BOG, reliquefaction. In LNG carriers or storage tanks, a small amount of LNG can vaporize and boil off gas. Heat exchangers are used to re-liquefy this gas, returning it to storage. Heat recovery. Heat exchangers are also employed for recovering waste heat from various processes, improving overall energy efficiency within the plant. Types of heat exchangers. Coil-wound heat exchangers, CWHE. These consist of a helical coil of tubes bundled within an outer shell. They are widely used in large baseload LNG facilities due to their ability to handle high pressures and severe temperature gradients, good resistance to thermal stresses, and large single unit throughput. They offer a compact footprint for large capacities. Brazed aluminum heat exchangers, BAHX. These are characterized by layers of corrugated fins separated by flat metal plates, creating multiple passages for fluids. BAHX are compact, lightweight, and offer a very high heat transfer area per unit volume. Plate heat exchangers. These are comprised of a series of thin, corrugated metal plates that create channels for fluid flow. Shell heat exchangers combines the high efficiency of plate technology with the robustness of a shell, making them suitable for demanding LNG applications, including pressure buildup units and main gas evaporators. Troubleshooting heat exchangers. Heat exchangers technicians face a variety of challenges, but a few problems are consistently at the top of the list. Fouling and scaling. This may be the most common and persistent problem. Fouling is the accumulation of unwanted material on the heat transfer surfaces. Symptoms are reduced heat transfer efficiency and pressure drop. Corrosion and mechanical failure. Leaks. External leaks are usually found by visible fluid drips, wet spots, or residue on the outside of the exchanger. Internal leaks are usually contamination of one fluid stream by the other. In the case of a cracked heat exchanger in a furnace, the risk of carbon monoxide leaking into a living space occurs. Troubleshooting usually consists of pressure testing, dye testing, and visual inspection. Solution procedures include gasket and seal replacement. Worn or damaged gaskets are a common cause of external leaks. Retorquing. Bolts on flanges may need to be retorqued to the manufacturer's specifications to ensure a proper seal. Component replacement. Cracked tubes or plates often cannot be repaired and must be replaced. Proper maintenance of LNG heat exchangers is a proactive investment that safeguards personnel, optimizes plant efficiency, and extends asset life, and ultimately contributes to the economic viability and environmental responsibility of LNG operations. And that's all the time we have for heat exchangers today. Thanks for watching. We'll see you next time.